So, sense time. Hike Vision provides a vertically integrated product. I think this is going to be a very, very successful category of devices for AI cities. And SenseTime provides deep learning middleware so that if you were a system provider, you're a server provider, and you would like to provide this capability, the software networks have been put together, NVIDIA software stack for system software has been put together, and you should be able to deploy into the marketplace. Now let me talk to you about cars. So we talked about AI city. I think that's going to be a very large market opportunity. Let's talk about AI transportation. The amount of work that we're doing in this area is really quite staggering. And the reason for that, of course, is because it's a large industry. This may be one of the largest industries in the world. People forget that the automotive industry and the transportation industry together is some $10 trillion large. $10 trillion large. A couple of orders of magnitude larger than the computer hardware industry. Just absolutely enormous. Now, the problem, of course, is that until now, there is no way to use computers to add value to driving. We don't know how to write the algorithms necessary to cause cars to be smart enough to understand what to do. Now, artificial intelligence has several components, and I broke it down here for you to see each one of the elements. The first element, of course, is perception. It's called sensing. What do I see? What do I see? What do I sense? The perception could be related to detecting cars, detecting people. It could be related to detecting scenarios. For example, a school bus is interesting, but a school bus that is stopped by the sidewalk is very interesting. And those two conditions, we would have to behave differently as an autonomous vehicle. Okay? And so we want to perceive objects, we want to perceive conditions. We want to reason, it's called reasoning, we want to reason about what we see. And the first thing we want to reason is, where are we? Where am I? Based on everything that I see, where am I? Reasoning. And the next part of artificial intelligence, based on what I see, based on the reasoning of where am I, where everybody else is, now I need to decide what to do. Planning. Okay? So the fundamental parts of artificial intelligence are four things. Of course, number one is learning. If you can't learn, you'll never be intelligent. Sensing and perception, reasoning, and reasoning in the context of cars is localization, and planning, taking action, problem solving, taking action. These four components of intelligence are completely evident in self-driving cars. And we have to solve each and every one of these problems. And so the first thing that we have to do is we have to build a supercomputer. That was job one. How do we build a supercomputer to put into a car so that we can process all of this software? Now, autonomous driving is not just yes or no. Yes or no is a philosophical question. Autonomous driving is a spectrum of solutions. And the spectrum of solutions, I've simplified here. The spectrum is much, much more complex, but I've simplified here into a couple of different milestones. And we're working with companies all over the world in each and every one of these different junctures. First, of course, is auto cruising. You're on a highway, you want to take your hands off completely. And you want the car to be able to drive itself. You want the car to be able to detect and recognize the surroundings. And you want the car to behave in a very, very safe way. The amount of software necessary to achieve that is really quite significant. It is not just detect a car in front of me, stop. That's called ADAS. Detecting a car, stop, is called ADAS. Self-driving cars, as I've just said in a second ago, requires reasoning and action planning, otherwise known as path planning for robotics. Auto cruise for highway, auto chauffeur, this one's really, really hard. This is like this. Take me home. After work, you say, take me home. And your car says something back in a very nice voice. Your car might say, would you like to stop at the store before you go home? Because the car has noticed that you have stopped to pick up dinner every single night before you went home. And you know that in Taiwan, this is true. All the young men in the office, in the room, they know, yeah, that's me. So now you can say, yes, I would like to have stewed pork on rice, which is one of my favorites. And it would stop by your favorite stewed pork on rice. You would pick up your stewed pork on rice, and now it would say, would you like me to take you home? That artificial intelligence experience is within the next 10 years. It's within the next 10 years. Auto chauffeur. And then full autonomy. There's nobody in the car. There is nobody in the car. And you call the car a taxi, it shows up, and some of it could be in just a digital fenced area, a special area like an airport or college campus. Some of it could be all over the city, but traveling rather slowly, 25 miles an hour. Some of it could be, in the future, your car is completely autonomous. You drive it if you like, you don't drive it if you like, and it can travel 100 miles an hour on a freeway, and it's completely, fully autonomous. We have created an architecture that allows car developers, whether they're a taxi as a service company, like Baidu in China, we just announced the partnership with them, Nutonomy in Singapore, okay, and countless other companies who are building taxis as services, a supercomputer that allows them to connect multiple cameras, maybe 8, 10, 12 cameras, LiDARs, maybe 4 LiDARs, radars, ultrasonics, and fuse all of that into one supercomputer and do artificial intelligence on every single sensor, all the way down to something that I'll announce today that I'm super excited about. This little tiny computer is the platform that many car companies can now take artificial intelligence right into the car in a cost-effective way. So if you're a car OEM, this is all you need. This is Drive PX2 Auto Cruise. This runs our deep neural network for sensing. It runs our deep neural network for reasoning. It runs computer vision algorithms for localization. And it runs computer AI algorithms for something I'm going to show you in just a second that's almost miraculous. Okay? So this is a computer called Drive PX2, the Auto Cruise version. The fully autonomous version is quite larger. It's 2 or 3 times larger than this, but this is the Auto Cruise version. Now, the first thing it has to do is detection. And so I'm showing you an example of detecting cars. Not only are we detecting cars, we're detecting the car volume. Because maybe you would like to not run into it. And so instead of just the cardboard of a car, we are detecting the entire space that the car consumes. But you know that when you're driving, you don't do that. When we are driving, we don't have a checklist that says, car, detect, check. Bicycle, detect, check. Moped, detect. 94 mopeds around me, check, 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 check. Pedestrian, check. Lane, check. We don't do that. What do we do? It's actually very interesting. Well, what we largely do is we detect where it is safe to drive. We actually detect the opposite. This is called free space. This is our these are running in real time, by the way. This is our network telling us where it's safe to drive. The opposite of object detection. Okay? Safe space detection. And notice it recognizes the road, it recognizes the people, and when it sees people, it turns red. You see that? We drive mostly like that. However, I think we drive even more intuitively than that. And I want to show you something that's really a breakthrough in artificial intelligence. We have a car, we have several cars that are all over the world driving around. This particular car, this model is called BB-8. There's another model called R2-D2. And there's one called C3PO. And so this is BB-8. This is an AI car. Let me tell you what's happening here. First of all, this car is driving by itself, what I'm going to show you. But that's not the amazing part. The amazing part is we did no software programming. We use a technology called imitation learning, where the car is actually learning from our actions. Just like we learned how to play ping pong, or just like we learned how to drive. When we learned how to play ping pong, nobody told me, my father didn't say, Jensen, you see that ball? Now apply Newton's physics. Okay? And based on how hard the person strikes, and based on the rubber of the bat, and the sound of that rubber when they hit the ball, you can tell whether the sponge of that rubber is high grip, right? High spin or low spin, right? And because you can tell with your ear whether it's going to be top spin or underspin or flat, the best players in the world, they conceal it by doing, so you can't hear it. None of that could be calculated using Newtonian physics. We don't play ping pong that way. We don't drive that way. Nobody taught my children Newtonian physics before they learned how to drive. And why would a 5-year-old play a video game that can drive? They don't understand Newtonian physics. And so we decided, why do we teach a car physics when we can just teach the car how to drive? Ladies and gentlemen, this is BB-8, learning how to drive. There are no lanes. It's not ready for production. Look at what's happening. No lane detectors. No car detectors. Wow, that was close. No grass detector. No pole detectors.
I'm not touching anything.
So cool.
Oh my gosh, that was close. No math, just AI. Look at that. Come on out, come on out. Amazing, right? No math, just AI. This is how we merge on freeways. We don't have to write math, we just teach it. And it can drive in the night just like we can. And in the rain.
Got it.
If you are not convinced that a machine can think, this should change your mind. We wrote no code. We wrote no code. We simply had this car follow us as we drive day in and day out, day in and day out. And one day, it started to do this by itself. AI car. Well, the computing platform necessary for AI is very complicated, and I think every nation and every country really needs to make some fundamental investments in the autonomous vehicle. Not just because the industry is so large and not because it provides so much benefits to society. Obviously, not only will our car be more fun just enjoy. We will have more productive time. It will be more relaxing. There will be a lot less accidents because a car never gets tired. An AI computer is always paying attention. And also because we might be able to completely redesign how cities are created. But more importantly, even higher level objective than that the autonomous machine, the whole concept of an AI autonomous machine is the foundation of the next industrial revolution. It is simply too important not to work on. I appeal to you that Taiwan needs to also invest in fundamental research in self-driving cars. And it is the reason why we're working with ITRI. And ITRI and NVIDIA will bring and invest in creating self-driving cars here. They've selected the Drive PX2, and we're going to create together Taiwan's first self-driving car. This basic investment not only will help us advance AI, it'll help us advance robotics. It'll help us advance the future of how computing is done altogether. This is a car. This is very, very serious. But in the future, we will have many home robots that's driving around itself at home. The future of IoT. This is a very important investment, and we're delighted to work with ITRI on this. If you would like to learn about self-driving cars, we will even teach it to the world. This is simply too important. And so we've partnered with Udacity. Sebastian Trun, as I've mentioned, is the father of the Google car. He made the first self-driving car on the road. Sebastian Trun is also a good friend and the founder of Udacity. We're going to partner together to teach anybody with an internet connection, because it's a digital education, digital course, the science, the engineering, and the art of designing a self-driving car. All the way from deep learning, sensing, to localization, the 3D mapping, to the kinematics of cars, okay, the control system of cars. This particular car will actually be what the students will use, and it's powered by the Drive PX2. The course will be available online. You should look into it. I think it's going to be a very important course, and I think it's going to be an incredibly fun course. Who doesn't want to design a car that drives by itself? This is a really great course to take. Well, we're working with so many companies now, one after another. Baidu is working with NVIDIA from cloud map all the way to in-car. Our partnership with Baidu is the first of its kind in the world. In order to have a self-driving vehicle, you want to have also a known high-definition map. Baidu is the leading map provider in China, and so now we will have mapping, AI algorithms, a high-performance computing software stack, as well as an AI supercomputer. We're working with Nutonomy. Nutonomy is partly a startup that came out of MIT, and it's already deployed in Singapore. The Singapore government is very progressive in allowing for self-driving cars on the road, and a lot of research in this area. Nutonomy. Volvo in Sweden. This is a company whose brand equals safety. The brand equals safety. The brand of this company is equal to safety, and they've chosen the Drive PX2, and the Volvo cars are now driving all over Sweden. And it will, I think, go to London very shortly. WePod. Several Drive PX2s inside. And all you have to do is on your smartphone in the Netherlands, you say, come pick me up, and WePod comes and picks you up, takes you to wherever you like to go. The first of its kind. And of course, you saw NVIDIA's BB-8.